All right, I guess we'll get started. I'm Carl Tascheron. I'm a first-year MS student in the Geography department in the Geosciences department at UMass Amherst. I'm in Morrill, right across from the break room. Come say hi. And today I'm going to do a quick demo on how to scrape websites using Python and Selenium. And the website that we'll be using as a demo is the GIS Jobs the GIS Jobs Clearinghouse, which is a listserv essentially of GIS jobs nationally. I have made this presentation a GitHub repository that you can view at the link in the chat here. Sada may have sent this out to you, I'm not certain, but it contains pretty much everything that you're going to see here. My presentation has a few last-minute changes, but mostly it's the same. And to run this demo yourself, all you need is to set up Selenium and also install pandas. Otherwise, it's just normal Python. So I'm going to share my screen and we'll get started. Let's see. Are you seeing my slides?
Black.
Or are you seeing my desktop?
I'm seeing
a black
nothing
screen
right now. Yeah.
You're seeing my slides or my desktop? I can't hear.
Neither, it's black.
Huh. Uh-oh. Screen share.
Now we see your Zoom. Oh,
Sharing. Now we
it's
see my
closed.
Zoom. Okay.
You trying to share just an application window?
Yeah. Oh my, that's unfortunate. Okay, we'll do my GIS Day presentation window.
Yep. We see your slides now.
All right. Yeah, unfortunately the Firefox window won't show up, which is unfortunate, but here we go. What is web scraping? Basically just collecting information from websites using code. And scraping is useful when a website has a lot of data and you want to collect and analyze it, but there's no way to actually export it to a usable format like a spreadsheet. Or there is no API where you can collect that using your code natively. Or maybe you want to archive a website and collect that information over time, see how a website changes, analyze differences. This demo is using Selenium. I like Selenium and chose it for this demo because it has a very low learning curve and it has the capability of doing pretty complex use cases such as scraping from websites like Instagram or Facebook. Your code probably won't work forever on a website like that, but you can get it to work much more easily than the tools that have preceded it. It runs within a browser window, and that scraping can happen to websites that change dynamically with things like JavaScript. You can click on elements like buttons and fill out fields. Like almost all Python stuff, it's free and open source and pretty well documented. Your other options there are plenty of options for scraping with Python. The most basic one that precedes this, the more classical version, is Python's requests library and Beautiful Soup. If your website is just plain HTML and there's no crazy JavaScript stuff going on, then this is a great method. It's very fast, it's very simple. Requests also can be used for API querying. So if you want to use Google Maps API or something, then knowing requests is a very useful skill. And there's some cross-compatibility between Selenium and Beautiful Soup. Beautiful Soup is the part that selects elements and collects information from them. But Selenium sort of builds a lot of that in, and you don't need to learn quite as much to start collecting information right off the bat. There is also Scrapey. Scrapey is very advanced compared to both of these options, but it's also much more complicated. It has its own shell, which means that you can scrape websites without touching code at all. And you can also scrape using some pretty advanced methods that can basically act as countermeasures against getting detected scraping. So a lot of big companies don't want you scraping their data. Scrapey is what you would use if you need to have, say, a botnet running in the Czech Republic doing this for you remotely. But both of those are much more complicated and harder than using Selenium. So today we're going to work with Selenium. So the libraries that you need to run my demo in your notebook are Selenium, Pandas, JSON, and XVFB. The last two are used to access data and read and write it. The Selenium WebDriver executable is necessary to do this. There are ones for Firefox and for Chrome and for Safari. The easiest one to install is probably for Chromium. The Firefox one is what I use, but it's all the same thing. As long as the website works in any browser, it doesn't matter what you use because the Selenium code is more or less the same. So to get started, all you need to do is import these things. The first one is the WebDriver. That's the browser object. There are some ones for preferences for configuring it, and then a few other Python libraries to keep everything, make all the information easier to deal with, and control our processes, and pandas at the end for reading and writing to tables. First thing you need to do is set up your driver. You pass it a URL. In this case, it's the GIS Jobs Clearinghouse. I'll open up that website for us in a new tab, and hopefully I can share that with you. Yeah, this is the GIS Jobs Clearinghouse. It is a basic website that has a table type layout. The jobs are posted on individual pages, and then there's this browser that lists all the jobs in a table. It uses JavaScript to cycle through the objects, and there is an item here for viewing all of them, but for the purpose of the demo, I want to show you how to do it with detecting the individual page counts. So back to, let's see, back to the presentation window. So the first thing you need to do is set up the WebDriver using the browser profile that you want, and I'm going to run this headlessly because you won't be able to see the window. Headless means that the window won't open up when you run the code. For testing it, you want to have the window actually appearing, so you wouldn't run it headless. When you want it to access the web page, you ask it to open it up using the driver object, and then you ask it to get the contents of the page using driver.get. The next step is to find the HTML element that contains the information that you want. So in this one, we are looking to get the information inside the table on the page, which is all the information in here. This is just an HTML table object, so we want to access what's inside there. We do this using the HTML inspector in Chrome, where you press Control-Shift-C, that opens up the developer tools, I think that's what it's called. That lets you select elements on the page. You need to find the element that contains the information you're looking for. And here it is. If any of you are familiar with HTML, everything on the page is an object within this list of objects, and the one we're interested in is a table, and it has an XHTML ID, which lets you identify that table, and in this case it's called jobs table, very helpfully. So we ask the WebDriver, which is our browser window, to find the element jobs table. And then we ask it to get the entire table. We then read in that table with pandas. Pandas has a function to read an HTML file or page into a pandas data frame. A data frame is essentially just a table in Python. It's sort of the standard for data science for storing tables within Python code. And our Selenium code here has already read it as HTML source, and it can be passed directly to the pandas read HTML object. So we're going to run this, and fingers crossed. Yep. So it accesses the information within the table, and we can see that the date, the title, the organization, and the location, which is all of the information stored in the GIS jobs clearinghouse table on the page here, is all seen in the pandas table. So we could export this to a CSV file and start working with it right away. And the next part of the demo will scrape the entire thing. But the first thing we need to do is close out of our original WebDriver. So this part of the demo does everything on the page, and it'll get a little bit more advanced. We have all the same imports here. We need to open up a new WebDriver window. Something here isn't right. I'm sorry, 1 second here. See if that runs. Yep. So we've got a new WebDriver containing that is now opened up to the web page, and we need to create a new data frame for pandas to store everything. We're going to collect everything on the page. We also need to know. So our plan now is to scrape everything on the page, which means to get everything from every one of these subpages. So if we think about doing this manually, we need to click on each of these numbered links, grab the table, and put it and collect it into one larger pandas table. So we would start at page 1, we would access the table, put it into pandas, we would then click page 2, put it into pandas, and repeat until we get to page 10, and then stop. And then we would have one big pandas table that contains all of the jobs that are listed here. So we start by making a new table. Shucks. Sorry, I need to copy over some more code here. So unfortunately, sharing my desktop is not working for us here. But I have the GIS jobs clearinghouse page loaded up, or I should. I think I need to copy some more old code over. Yeah, here we go. You get our web page, and then I need to. There we go. I'm now using the same code that found the table. I'm using the same principles that find that table to find us the button for all of the pages. So we are finding all of the pages in this list here that go from previous 1, 2, 3, 10, next. We find the page numbers for all those pages, and then we will store them into a list. So we can use the text within that list of links to create a list that has previous 1, 2, 3, 4, 5, 10, next. We then need to figure out how many pages there are total by using the second to last value within that list. So the total number of pages is 10 because 10 is the second to last one. We then need to loop through the web pages that are, we need to loop through all of the pages within the GIS jobs clearinghouse table. So I will show what that looks like by now sharing the window for the web driver that we've got opened up. So you should see my web driver now, where we have the available positions. We are now going to tell Selenium to click through each of those items and store it to a table. And I've added a bit of delay, so you should see, if this works, you should see it click through each of the pages individually. Yep, so it's clicking through all the pages, 5, 6, 7, 8, 9, 10, and it has stored all of that into a pandas table. So back to our demo. It stored all of that to a pandas table. What you saw here is just a typical pandas loop. This is a typical Python loop where we are asking it to to do this loop 10 times using the total number of pages variable, which is 10. We're asking it to stop once it gets to 10. And then each time it goes through a page, it will use the it will use that pandas read HTML to read in the HTML from the table that it currently sees. It will then concatenate that pandas table with the jobs.df table that we've made that is used for storing everything. Once it does that, it clicks the next button on the page. So it's not actually clicking the numbers, but it's actually clicking the next job button. It clicks that, and then it's ready for the next page. This right here is just for demonstration purposes. You don't need to tell it to delay, but on many websites it's a good idea to add some sort of artificial delay, because if you do it all at once and ask it to grab 50 pages in a row with no delay, they may detect that you're scraping the page and kick you off. So in terms of scraping detection, adding delay between the steps in your for loop is probably one of the primary ways to make sure you don't get banned. So now let's take a look at what shows up in the jobs table. We have 90 rows containing each of the jobs that were on across those 10 pages. So it's our first one here, Geographic Information Systems Analyst for the Calvert County Government in Calvert County, Maryland. That should probably be our first one. Yep. And then our last one, Senior GIS Analyst. Well, it appears that's on page 9. So my loop unfortunately stops one early, but that's an easy fix. The last one in our table is the Senior GIS Analyst for the City of Fort Lauderdale. Since the table looks all right, we now export it using the jobs.df to CSV function so we use the to CSV function in pandas to export our file. And that's it for the Selenium stuff. So I'll show you what came out the other end in some detail. This is the output table. We can see that the location data has some inconsistencies, and it's not particularly clean. Some of these items say, Calvert County, Maryland, Santa Monica, California, fairly easy to parse locations. And then we have things like this that say, or remote, Portland, Oregon, and other locations, headquarters in Birmingham. A lot of dirty data. When you scrape information off the internet, a lot of it is human entered, and it won't be immediately parsable. This is a good case of getting data that you need to clean up a bit before you can use it. I imported this into QGIS, and let's see if we can get it up here. Sharing QGIS. I've imported into QGIS, and here's our output map of locations. So in order to get this map, I had to geocode all of the locations. And because the information is dirty, not all of them could be found. So only 56 of the 90 items in that table actually were able to import into QGIS, because the rest of them couldn't geolocate. I used a free plugin called MMQGIS that has a web service geocoding plugin, and it just takes a CSV. For the web service, I used OSM, OpenStreetMap, so it's a free API where not everything really worked perfectly, and only 56 of them came in, but you might get better results with Google, which is better at handling address information that is a bit funkier, where you have things like, you know, like headquarters in Birmingham, Alabama, you know, it might be able to just read that and say Birmingham. But if you want it to come in seamlessly and be geocoded easily, you do need to clean up the table a bit. In a case like this one, 100 items you could probably clean up in Excel pretty quickly, but sometimes when you do a scrape, you're dealing with thousands or tens of thousands of items, and you need to start writing more code to clean that up. Some of the geocoding also resulted in these funny display names for things like, this is for City of Topeka Police Department, and it gave us Allstate Pawn Shop. So that is the end of the code demonstration, and I'd like to open it up for any questions you all might have. I'm sorry that it did not go perfectly with the browser window things, but I hope that showing the demo of everything getting selected was useful to see it actually in action.
That was excellent, Carl. Thank you so much for that demonstration. It's actually a lot less intimidating to scrape now that I've seen you do it like this time. My one question to you, a question and a comment. One, I think the city of Topeka actually is just a big pawn shop. I'm not sure.
You are probably right. I haven't been there,
be.
but I take your word for it.
I've never been. But my question to you is about that timer that you added to delay slightly. So is it a thing? Are we typically not? Are we typically discouraged from scraping data off of public websites or that sort of thing? I'm just sort of curious why we would, like, if we were detected, people would like shut us down.
Well, it depends on who we're scraping from. So if we think about the motivations of the people doing it, who we're scraping from, the GIS Jobs Clearinghouse is probably not likely to care that you are running something to just scrape some GIS jobs postings. They'd probably be happy to hear that you've done that. But if it's something like Facebook or Instagram, they take very aggressive and active countermeasures against scraping. Instagram, I've never been able to scrape more than 10 pictures from Instagram before I get banned. And that is with the world's most advanced scraping tools. They really don't want you to, because for big tech, their biggest asset is the data and assets that they've collected. So if people are coming in and taking that data, they see that as stealing. As researchers, you know, we need to be able to get our hands on data to work with it and analyze it and think critically, you know, be able to do critical research. But big tech really does not want you doing that. So Google and Facebook both take pretty aggressive steps to stop you from scraping, but most websites don't. Most simpler websites not run by big tech don't care. So as far as the delay goes, the time.sleep part of the code, it's polite. It's polite to delay your scraping, because if you tell it to do everything in order, let's say we're scraping absolutely everything off the website, 10,000 pages. If you tell it to just access 10,000 pages over and over again, that might overload their server. It might be some small, cheap server that can't handle someone asking for that much information at once. It might be only able to handle a actual real life person going in and clicking things individually. So in short, it depends on who you're scraping from, how much you're trying to avoid being detected or banned, and what the website can handle.
Thank you very much. I appreciate that.
Yes, thanks for asking. Anyone else have any questions?
I mean, if no one else has a question, I do have a follow-up.
Sure.
Not necessarily a follow-up, but that online geocoding service that you brought into QGIS, is that like, what are the parameters for that? Like, it just took your city and state and kind of like geocoded it from your location field?
Let's see. So the plugin is called CSV, or it's called QGIS, and it's a free geocoding plugin for QGIS that takes CSV files, and then it can run it through the web service of your choice. I think the options are OpenStreetMap, Google address search, and Bing Maps address search. OSM is free. The Google Maps ones are not, and Bing ones are not. All you need to do is give it a CSV and tell it which column to read from. So in this case, it was the location column. And I think you're supposed to, on the GIS Jobs Clearinghouse, like for it to be geocodable, it needs to be city and state. If it gets any more funky than that, like saying or remote in parentheses at the end of the name, that's likely to break the geocoder, and a lot of geocoders can't handle that. The OSM one breaks for like the simplest errors and weirdness about the addresses. The Google one is a little bit harder to break.
Thank you. That's awesome.
Yeah, thank you. As you said, Selenium is not very intimidating once you get started. I got started doing the more classical method of using requests and Beautiful Soup. It's a horrible pain. It's like it's all done blind. You need to access the information and then parse it and then sift through it with Python. With Selenium, you're looking at it in an actual browser window, and you can say, click this, click that. You can use the browser window to debug as you work. You can continue to control that browser window as you work. So as you're entering new code and running it, you have a browser window that's up and running separately as like a separate process. And then you pass it commands and see what the output is. And you can do it all visually and in real time, which is an incredible advantage over Beautiful Soup and requests.
Oh, nice.
Yeah, the biggest, so the part that I hide that's kind of annoying is getting the WebDriver installed. That part can involve some system configuration things. On my computer, which runs on Linux, it was a little complicated. It's probably easier on Windows, and the easiest way is with Google Chrome or Chromium. There's a lot more documentation for those two browsers than there is for what I use.
Good to know for a first timer.
Yes, so if you want to try out the demo, just get those prerequisites set up, get Chromium set up with the Selenium WebDriver, and then just try running the notebook. You'll need to change the code slightly to use the Chrome driver. Kind of wish I included code for that, but there's only time to do it with Firefox. If you can get the Chrome WebDriver working and adjust the code accordingly, then the rest of it should just run without bugs. I've tested on a few different computers.
Thanks. I have your GitHub open right now, so good. Thank you.
Yeah, you can see all my other
I won't
abandoned
look.
projects. Oh, I mean, look if you want. There's some useful stuff in there. Most of it's just junk.
Love it.
Okay, well, if there aren't any more questions, I'll just let you all go. And thanks so much for coming.
Thank you very much.
Thank you, Carl.
Take care, everybody.